Hello guys, welcome to my YouTube channel. I am Mohammad Anas of third sem Department of Electronic Communication Engineer studying in Sri Venkateswara College of Engineering. In this video, we are going to learn about the Fourier series. Fourier series is a mathematical tool used to represent periodic function. It was developed by French mathematician Jean-Baptiste Joseph Fourier in the early 19th century. Fourier series decomposes a periodic function into a sum of sine and cosine functions. In this problem, we can see how the Fourier series decomposes the function into a sum of sine and cosine. The representation of a periodic function. A periodic function of x with period t can be represented by a Fourier series. The Fourier series of f of x is an infinite sum of sine and cosine function as I told you. The coefficient of sine and cosine terms determine the amplitude and frequency of the harmony. This is the graph of periodic function f is shown in the figure. The Fourier series formula. The general formula for the Fourier series of a periodic function f of x is equal to a naught plus e a n cos n omega x plus bn, where n b sin n omega x, where n equals to 1, comma 2, comma 3. Fourier series formula f of x is equals to 1 by 2 a naught plus summation of n equals to 1 to infinity an cos of nx plus summation of n equals to 1 to infinity bn sin of nx, where a naught equals to 1 by pi summation of minus n to n f of x dx. An is equals to 1 by pi minus infinity to infinity f of x cos of n pi dx. Bn is equals to 1 by pi summation of minus infinity to infinity f of x sin of ns dx. N equals to 1, comma 2, comma 3. The calculating Fourier coefficient. The Fourier coefficient can be calculated by using the following formula. An is equals to 2 by t integrating f of a cos of n omega x dx, where omega is equals to 2 pi by t and bn equals to 2 by t. Fourier coefficient using SCI lab. F of x is equal to a naught by 2 plus summation of n equals to 1 to infinity an cos of n pi x by L plus bn sin n pi x by L. The coefficient Fourier the corresponding Fourier coefficient are: step 1, a naught is equals to 1 by L integrating 2L f of x dx. Step 2, an is equals to 1 by L integrating 2L f of x cos n pi x by L dx. Step 3, bn is equals to 1 by L integrating 2L f of x sin n pi by x by L dx. And integration are over a single inverter in x of 2L. The convergence of Fourier series. The Fourier series of a function can be converged to the function itself under the certain condition. If a function satisfies the direct condition, its Fourier series converges to the function at a point of continuity. At point of discontinuity, the Fourier series converges to the midpoint between the left and the right limit. Fourier series for even functions continue. In the initial minus L lesser than or equal to x lesser than or equal to L. F of x is equal to a naught by 2 plus summation n equals to 1 infinity an cos of n pi x by L. A naught equals to 2 by L 0 to L f of x dx. An equals to 2 by L 0 to L f of x into cos of n pi x by L into dx. Applications in signal processing. Fourier series is widely used in signal processing for analyzing and manipulating signals. It allows us to decompose a complex signal into a similar sinusoidal components. By manipulating the Fourier coefficient, we can filter, compress, or modify the original signal. What is Fourier transform? Fourier transform is a mathematical method to convert a function in the amplitude versus time domain to amplitude versus frequency domain for non-periodic function. Fourier transform does for non-periodic function what the Fourier series does for the periodic functions. This is the Fourier series and this is the Fourier transform. Applications in image processing. Fourier series is used in image processing also. Fourier series has application in image processing and computer version. It is used for image compression, noise removal, and enhancement. Fourier analysis helps to identify patterns, edges, and frequency in image. Applications in communication, Fourier series applications in communication. Fourier series plays a critical role in communication system and modulation techniques. It helps in transmitting and receiving signals effectively by encoding information in different frequency components. Fourier analysis is used for channel equalization, filtration, and demodulation. Applications in physics. It also plays a widely role to solve the equations in physics. Fourier series is extensively used in physics to solve differential equations and describe periodic phenomena. It is used in quantum mechanics, electromagnetism, and wave theory. Fourier analysis is critical for understanding phenomena like interference, diffraction, and resonance. Conclusion of the Fourier series. Fourier series is a powerful mathematical tool for representing periodic functions. It has diverse applications in various fields, including signal process, image process, and communication and physics. As I told you, understanding Fourier series and the applications can help us analyze and manipulate complex phenomena more effectively. This is the Fourier series syntax. Thank you for watching my video. So please like and subscribe.